I hope that it's going to be visible. I'm not sure. So, hello and welcome. I'm Ákos, and as Spiros well said, we are going to talk about WebSocket Protocol. At first, I assume that you are familiar with HTTP protocol itself, but maybe some refreshing is not that bad. I made this capture this morning about a simple page. You can see one client, or you cannot see my IP because you can see the destination IP. I made one request. It was from my port, initial port, to the HTTP port of the server. And then another connection came, a new TCP connection. And then the server replied, and I did my get command, and then I started to get some data. But as you can see, I opened, or not me, but Google Chrome opened several another ports just to make the transaction faster. So what did we see? It was a normal HTTP traffic, a simple page. It was static content, some images, but really not much. And it was a simple get command. So we had our PC. It was a laptop, but never mind. And I started my communication from this port to the web servers, port 80, where the HTTP server is listening. Okay, I guess it's quite understandable. But then we ended up the communication, so I could get this whole page with several TCP connections. So if I can count right, I had 6 TCP connections, different connections. Maybe they last only for 1 millisecond or rather less, because it was just a CSS file or something like that, but it was another TCP connection. So as you can see, it's not the best way. Maybe not the best way if you have to be concerned about web applications which are involved. At first we had web application like, okay, it's not a web application, you just download the page, you have a browser, you have a static page, you downloaded it, okay. That way, this several TCP connection method is going to be alright. But we have more developed applications, so we have to be concerned about bidirectional communication. So let's say you have a chat client, you are using Facebook chat, and you are writing to somebody, and somebody writes to you. In that communication, you have to, your browser needs to get data from the server. And the server cannot push you this data. So the solution is, this is what it called like HTTP polling. You have this web application running on your browser, and it's like an overly attached annoying dog to the HTTP server. Do you have any update? Do you have any update? And if it has, it sends the update. Please come in. Yeah.
Yes. Με ποιο μιλάω, ποιος είναι με εσάς. Τι ώρα τελειώσει τα πολλά.
Μέχρι τις 2 είμαστε δίπλα στην αίθουσα.
Επειδή δεν έχει κανένας κάτσα αυτή την αίθουσα.
Κάθε εβδομάδα, στο κειμένο όλο το εξάμεινο. Δηλαδή κρατημένη επισήμη.
Επειδή δεν ήταν κρατημένο στο σύστημα κάτω, γιατί θα κλείσει και εγώ αυτή την ώρα. 12 η ώρα δηλαδή, μέχρι τις 2.
Όλο το εξάμεινο. Είναι για μεταπτυχιακό, όλο το εξάμεινο.
Εντάξει, καλώς, ευχαριστώ πολύ.
So, let's continue. We have this web application, and as you can see, it needs a lot of hassle to get the information from the HTTP server. It needs at least 2 separate connections, but as we saw, just a simple connection, just a simple communication made 6 different TCP connections. So if you think about Facebook, it could make a lot of TCP connections, and it can be really trouble for a web server to maintain these connections. So it is going to be far more than 2. Plus, there's the HTTP overhead. You have HTTP connections above the TCP connection, so you are sending all the way the HTTP headers if you have just one message from your girlfriend and you just want to get this, but you have to bundle it, all the headers. And it's quite heavy as compared to the payload. And even it's not that easy for the client itself, because the client on the browser has to track all the new connections and all the new incoming data, because it is asking for data and the server replies. And okay, so for this data I get this reply, okay, and then I send this. So it's even on the client side not that easy. So the idea is behind WebSocket that we can do basically just one TCP connection, and in this one TCP connection we can make a new protocol. It is going to be WebSocket Protocol, and our web application can communicate both ways with the HTTP server. So the HTTP server can freely send data to our web application, and our web application can do it also. So it's like a regular communication. But it just needs one TCP connection. So this green is TCP connection, the white is WebSocket, and in the white there's the communication. Okay, to build up this communication, at first we have to open a TCP socket, a TCP connection, and this is made like the regular way. But there's going to be a handshake from the client. This is a regular HTTP GET command, but then after that it's related to WebSocket. Okay, we are defining the host. These fields are needed for a normal handshake. So let's see, there's a connection upgrade request. So the client wants to upgrade to a WebSocket connection. It can be declined. Then if a client has a fallback situation handling, then the communication can go on about HTTP. Okay, there's a security key, which is a randomly generated key, encoded, and this is what is going to be used to encrypt the communication. Okay, there's the origin, so it can be checked if this is a well-known application or not. This is also by security reasons, and the others are I guess pretty self-describable. We have a handshake from the server. It's different. Okay, this HTTP header on the top is the regular one. So we can upgrade to WebSocket because the server also knows the WebSocket technology. Connection upgrade. This is how the server says that okay, we can connect over WebSocket, and there's an accept which is generated from the client's WebSocket key. So it means that this request, handshake request, is totally accepted. And then the communication can flow above WebSocket protocol. This WebSocket connection built up. So we have all these positive sides of WebSocket communication. Yeah, I think I have talked about it more or less. One is important, that we have also frames in this communication, which is rather independent from the frames like in TCP. So you can have, let's say, 2 frames in WebSocket, which can be 4 frames in TCP or 1 frame in TCP. It's independent. This is how one frame looks like. I have to say I'm not really prepared of each field. I hope it's not a problem. Spiros, if you want, you can.
Just in case. Are you prepared to explain some of them? Or
yeah, some of them. Like.
Do you have some slides about this?
No.
Fields?
About these fields, no.
So then discuss about the general idea, and then I will show you some details from them.
Okay, so Spiros is going to be tell the details. I'm sorry about not preparing from that. For me, what seems the most important from this packet
is the pervasive class.
Okay.
You can switch off the lights.
Here?
Yeah. And the other two, well, the same switch.
Yeah.
There are 2 more buttons.
Where?
The thin buttons.
Ah, these are buttons. I thought these are holding the wall stuff. Okay, so for me it was not so necessary, but there's a masking key. For me, this security aspect was what is interesting. Yeah, I know it's all described in the RSC.
Actually, the opcode is important and the payload length. The rest is obvious.
Yeah. The rest is obvious. But maybe this masking is not that obvious.
And the masking key has to do with the security key that is exchanged between
Right?
at the opening of the.
Yeah, you're right. Good student. Okay, so let's leave it there. From the opcodes, you can have control frames. You can have this ping and pong, which is quite similar to the ICMP ping request. They can maintain the connection, and they can check if the other part is answering or not. They have a timeout also, right? Okay, if you have additional to this.
No, later that I
Okay,
send the
good.
opcodes, the available opcodes, and show the codes that correspond to this ping and pong.
Okay, so brace yourselves. Okay, so with this packet, we could reach a small overhead. We were talking about overhead with HTTP. Small overhead for small payload, so it's not that nasty as it was with HTTP. We can have less traffic, and it can use less resources, as you could think. And even if we have large data, we can reach a smaller fragmentation than with HTTP. Okay, and talking a bit more about security, I think this is from your slides. Okay, so I really like this approach. You will see. In this situation, we have an HTTP cache, a proxy, in our network. And let's consider that we have a victim browser or somebody who is going to do some really bad stuff with our network. We have this HTTP cache, which is a cache. So when you have a request from your network and it goes through to the outside network, its goal is to cache the answer, then the network traffic can be made quicker. So if you forge a malicious data request it's a normal request. Let's say it's going to facebook.com. But the answer is not coming from Facebook. But it has malicious data inside, and this HTTP cache caches the answer. Then when all your network, all from your network, the clients are asking for the same request to Facebook, then they are going to get this malicious data back. It's like proxy poisoning or something. I don't know, I really like this idea. It's nice. This is what we were talking about, this caching proxy poisoning. Then what's inside this packet, the masking. We have a rule that if a traffic goes from the client to the server, it must be masked. Yeah, it's nice. Must be masked. So we have this. I have a slide for it. But if the traffic is coming from the server to the client, it must not be masked. So it's not masked. And if you think about it, if a masked request is going out here, then let's say we have these two different clients, and if they are masking with random values, the request is going to be different. So the caching proxy itself is not going to be so efficient in caching, but in security reasons it's going to be okay because it's not caching the same answer for these requests. Okay, so how masking is working? We had these 4 random generated octets from the beginning, and we have our clear text data, and we make this bitwise XOR with the payload and the mask, and we have this mask data, and we are sending both the mask and the mask data to the server. So this is how it's working. I guess it's not that complicated. So thank you for your attention. I hope that I covered almost the main topics, but Spiros can add up more.
Still want a good presentation, I think.
Thank you.
Do you want something to ask?
Yeah, the questions, if you want. Okay, thank you very much.
This is your cat?
No, I guess it's internet's cat. Rather.
What is name?
What?
What is name?
I don't know. Internet cat, yeah.